Let us return to the list of increasing leverage point effectiveness from Meadows. In the tutorials, we have seen plenty of examples of how changes to the structure of information flows through, for example, mandatory emission reporting or mandatory product labeling can influence both firm and consumer behavior. Imagine how behavior would differ if we had constant visual feedback on our carbon emissions as shown with special cameras in the 2015 documentary film Raising Extinction. And while share Meadows her belief that information provision can be an important lever for more sustainable behavior, I also wanted to share an observation that illustrates how information can be a double-edged sword. That is, correcting misperceptions can both have resource conservation effects, but also boomerang effects. In an experiment on electricity use, Bairn and colleagues found that households that overestimate relative use and low users both respond by consuming more. The fifth most effective leverage point is to change the rules of the system. Here we can think of introducing taxes, bans, or legal liability. Introducing taxes are listed as a higher leverage point than changing the level of a tax because of non-linearities around zero. For example, the difference in behavior from introducing a 10-cent tax on disposable plastic bags is likely to give larger effects than raising a tax from 10 cents to 20 cents. We have touched on the benefits of taxes vis-à-vis bans in the second lecture. You may remember that I was somewhat hesitant to take a strong position in favor of a monoculture tax because of some implementation challenges and possible risks to short-term food security. I'm more convinced of the need of a plastic tax, not just the tokenism of focusing on plastic bags. This plastic tax should be set high enough to stimulate the adoption of plant or fungi-based alternatives. And arguably, the tax should be combined with bans on certain applications, such as single-use items or fishing nets. The only potential drawbacks to such policies could be an increased demand for paper, bamboo, cotton, or other renewable alternatives with additional pressure on land use. Yet, as Tinbergen already noted, you need at least as many instruments as you have objectives. Given certain land's protected area status is an example of leverage points for biodiversity conservation by changing rules. The recent study by Washope and colleagues revisits protected areas effectiveness estimates for some 1,500 protected areas. They show that many effectiveness studies were either a before-after comparison of protected areas introduction or a control intervention comparison after the protected area had been introduced already. Washope and colleagues use a matching technique to reassess effectiveness based on a before-after control intervention difference in difference type of comparison. This reassessment shows slightly more protected areas as having benefited populations of waterbirds. We should note, however, that the protected area effectiveness is still likely an underestimate because a bias to focus on more common waterbird species. Also noteworthy is that amongst the protected areas that did not show improvements, half seem to have healthy populations of waterbirds, as these had either increasing or no noticeable population trends. Joppa and Pfaff show that currently most protected areas are situated far away from centers of economic activity and are biased toward high elevation. This can also be seen from the Venn diagram from Pim and colleagues, where protected areas are concentrated on lands having below median human footprints. Pim and colleagues, their paper explores the conservation strategy once proposed by Wilson to extend protected areas to half of land surface, and whether this would be sufficient to protect 85% of terrestrial species. Pim and colleagues find that 50% protected area can indeed protect 85% of species, but also note that focusing on protecting large areas is not always more fruitful than protecting biodiversity hotspots. Endemic species distribution maps by Joppa and colleagues, such as the endemic plant map depicted here, shows where we can find regions rich in unique biodiversity. The map also shows that many endemic species-rich areas happen to be in rather populous regions. In Walshop and colleagues, we can read that ideas similar to the Have Earth proposal are now gaining traction. Dinnerstein and colleagues advocate the idea to give 30% of lands and oceans a protected status by 2030 and to raise this to 50% by 2050. These proposals have enjoyed a mixed reception. For example, Busser and colleagues argue that the Have Earth proposal may increase polarization between people and nature. Protected areas help little to address other systemic threats such as climate change, and instead they argue that we should move to a whole Earth strategy for cohabitation with nature. Other organizations like What the FWWF fear that the 30 by 30 strategy will lead to displacement of indigenous people from their traditional lands under the guise of conservation, and that once appropriated, that the protection will be undermined for corporate interest. The risk of weakening protection is known in the literature by the acronym PADD, or Protected Area Downgrading, Downsizing and Degazettement, where degazettement refers to the loss of protected status altogether. Golden Kroner and colleagues analyzed over 3,500 of such PADD events and found that most, some 60%, are associated with industrial resource extraction. The analysis by Walshop and colleagues also demonstrated that good management can aid protected area effectiveness. This echoes earlier findings of protected area effectiveness for waterbird conservation by Amano and colleagues. The latter also highlights social-political instability as an important threat to biodiversity. Finally, see Watson and colleagues for more information on the widespread underfunding of existing protected areas and other biodiversity conservation initiatives. The final observation in relation to protected areas that I wanted to share is in line with Sin's green paradox and complicates the before-after control intervention comparison provided by Walshop and colleagues. That is, the green paradox suggests that announcements of more stringent environmental policy can have the unintended effect of stimulating resource extraction until the policy is implemented. Sin formulated the paradox in the context of climate policy, and Cairns argued that a green paradox is somewhat unlikely for fossil fuels due to difficulties to shift production between periods. Yet, Llopis and colleagues show that the green paradox does occur for assigning protected area status in Madagascar. Their results suggest that the process of establishing protected areas first reinforced ongoing deforestation, but later led to significant reduction of forest loss rates.